So now we will get the Laplace of cosine bt. Integration of cosine bt times to the kernel of transformation e raised to negative st dt from 0 to positive infinity. So this term can be integrated using integration by parts. So our u here is cosine bt. Our du is negative b sine b t dt. Our dv is equal to the differential part, which is e to the negative st dt, and integrating this, we can get the value of v, which is negative 1 over s e raised to negative st. So from the definition of the integration by parts, uv cosine bt u times v, which is negative 1 over s e raised to negative st, times the minus the v du, which is negative 1 over s e raised to negative st, times our du, which is negative b sine bt dt. Now we can move the coefficient outside the integration. Negative cosine bt 1 over s e raised to negative st. Negative times negative times negative is negative of bs b over s times the integration from 0 to positive infinity of e raised to negative st times sine bt dt. So now we get some integration by parts again. So u is equal to sine bt du, just the derivative of this is b cosine bt. Our dv is equal to e raised to negative st dt, and integrating this, you can have the value of v, which is negative 1 over s e raised to negative st. So by uv minus v derivative of u, negative cosine bt 1 over s e raised to negative st, negative v over s times u sine bt v negative 1 over s e raised to negative st minus the integration of 0 to positive infinity of v negative 1 over s e raised to negative st du, which is b cosine bt. Let's distribute this term, resulting to negative cosine bt 1 over s e raised to negative st. Negative times negative is positive. Positive b over s sine of bt e raised to negative st. Negative times negative times negative is negative b times b squared, s times s over s squared, times the integration of 0 to positive infinity of e negative st cosine bt. So notice that this term is like this term. So we can let this term into y, and writing this again, cosine bt. So y is equal to negative cosine bt 1 over s e negative st plus b over s sine bt e raised to negative st minus b squared over s squared. This term is y. So combining like terms. Let's transpose this term here. Y plus negative become plus because we will transpose b squared over s squared y is equal to negative cosine b t 1 over s e raised to negative st plus b over s sine bt e raised to negative st there. And factoring this out will turn into 1 plus b squared over s squared 1 over s e raised to negative st times negative cosine b t plus b over s it's just b sine bt. So finding the limits of this term from 0 to positive infinity, we solve to 1 plus b squared over s squared equals 1 over s times e raised to negative s, higher limit which is positive infinity, times negative cosine of b times positive infinity plus b sine b positive infinity minus lower limit 1 over s e to negative s times the lower limit which is 0, negative cosine b 0 plus b sine b 0, and this e, a number with an exponent of infinity, is equal to 0, and distributing it, this term will become 0. So y 1 plus b squared over s squared equal to 0 minus this term is 1 over s times negative cosine b0 is 1. And this term is sine 0 is 0. So y plus b squared over s squared is equal to negative times negative is positive 1 over s. 1 over s. Simplifying it to get y. Yes. Simplify this term. Y times s squared plus b squared equals 1 over s. Y here is equal to 1 over s times s squared over s squared plus b squared. So cancel, y is equals to 1 over s squared plus b squared. So we can say that the Laplace of cosine bt is equals to 1 over s squared plus b squared.